Hello, my name is Christie Craig, PhD candidate and field officer for the Endangered Wildlife Trust. Today I'm going to be presenting some work that myself and Sally Hoffman have been working on, along with our supervisors Tanya Smith, Liz Underhill and Peter Ryan. My PhD is based at the Fitzpatrick Institute, and I'm going to be presenting some of the work from my second chapter, looking at assessing the state of the blue crane population with a focus on the Western Cape. And this work is funded by the Leiden Conservation Foundation, and some of my broader project is funded by Eskom. So the blue crane is listed as globally vulnerable on the IUCN Red List, and this was due to an estimated decline of 50% since the 1970s. And some of the reasons for this were grassland degradation, poisoning, power line collisions, and a number of other factors which led to the decline of the species. However, the decline hasn't been uniform across the country, and that's what I'm going to be going into a bit more with today's presentation. So we call the blue crane a near endemic because they are almost entirely found within South Africa. There's a very small population up in Namibia of, last count was less than 30 birds, and this population has been declining. We then have a population in the eastern grasslands, which used to be the stronghold for the country, and what I'm going to show you through some of the data that we've been looking at, this population declined quite significantly. They estimate that from the historical numbers, this population could have declined 5 to 90%. So there today is a fairly small remnant of the former population in the eastern grasslands. And then we have quite a significant population in the Karoo. Around 30% of our blue cranes are found within this arid, fairly untransformed habitat. And then we find more than half of our blue cranes in the Western Cape. And this is quite interesting because historically they didn't occur in the Western Cape. But as fynbos was cleared for agriculture, blue cranes started to move into the agricultural areas and have since done quite well. So in the Western Cape, we see cranes using these very transformed agricultural landscapes, these intensive wheat and pasture lands. And there are a number of challenges that come with this, and makes it quite a challenging landscape to conserve cranes in. However, historically, the cranes seem to do very well in this agricultural landscape, as I'll show you with some of our data. So we have some really useful citizen science data to look at the trends across the country. And this is what Sally Hoffman did for her PhD. She looked at the South African bird atlasing project, which essentially, as anybody who's interested in birds can go out into a geographic unit, which we call a pentad, or in the first project, a quarter-degree grid cell, and record any bird species they see within a certain time frame between 2 hours and 5 days. And that list can then give us something called a reporting rate, which tells us how often someone is seeing a particular species in an area, and that can give us an idea of the abundance of the species. So this is what Sally did with her PhD. She compared SABAP1 with SABAP2. So the first project ran from 1987 until 1991, and the second project from 2007 is ongoing. So Sally had looked at this data until 2012, and then together we have updated this data until the latest data that has been submitted. So what we're looking at in this map is a comparison between SABAP1 and SABAP2. And what it does is it compares the reporting rates and looks at the strength of the change in those reporting rates. So a red or orange square indicates a strong decline, and a green, dark green or dark blue indicates a strong increase. and the yellow, light green, and the yellow and the light green indicate that there's not been a significant change. So overall, we found that 27% of these grid cells indicated a strong decline, and you can see that most of these are within the grasslands, and that's what I mentioned before, is major declines in the grasslands. We saw 18% of these cells had a significant increase, and you can see these are mainly in the Western Cape, a little bit in the Karoo, and you can see in the Karoo a lot of the cells are indicating that there's not much change or weak change. So we find that 63% of the Karoo cells, quarter-degree grid cells, indicate that there's not been a strong change. This population seems to be quite stable. So we also then looked at where a cell had gone from reporting blue crane in the first SABIT project to not reporting them in the second SABIT project, indicating that perhaps in that particular area there'd been a local extinction for blue crane. So what we found in terms of this is obviously we also had cells where it went from a 0 reporting rate to being reported. So we compared all of these and then looked at the net loss. So what we found is that compared to cells where cranes had moved in, compared to cells where cranes had moved out, we found that there had been a 5% net loss. So 5% of the blue crane range has been lost compared according to this data set. So another citizen science data set that we have available to us, and another citizen science data set that Sally had a look at, was the coordinated able-faunal road counts. So what these essentially are routes that citizen science can go out and drive, and this happens twice a year on the same date, so in July and January, and people go out, and there's a set methodology. You go out to the same route, you drive, you stop every 2 kilometers or when you see a bird, and you record a certain list of species that are of interest. So blue crane is one of the species that is on the CAR list, and you can see here on this map all of the CAR routes, and you can see it overlays really nicely with the blue crane range. So Sally looked at this data up until 2010, and then we went and updated this analysis with the latest data. So you may have seen the recent Young and Harrison paper that looked at the Western Cape blue crane car counts, and it gives a really nice overview of what's been happening in these precincts, which have been surveyed the longest. They started before any of the other precincts started, and they've had quite a nice, complete, fairly good participation in these precincts. So these data look like they could potentially have some interesting trends, so we decided in discussion with Danella to investigate these a little more and have a look at what's happening with the trends in these populations. So one of the shortcomings of a long-term citizen science project is you're bound to have missing data. It's a voluntary project, and people won't get to every route every year. So even the Overberg and Swartland, which are quite well surveyed, do have some missing data, and one of the ways that we wanted to fine-tune this analysis is to account for that. So here is actually the Overberg precinct, and in the red is the routes that were counted, and the blue are the routes that were missed. So what we can then do to try and fill in these gaps is using something called imputing, which is a method that Les Underhook came up with. And using a chi-square process, you can look at what has generally been recorded in this route in the future and in the past, and what has generally been reported in that year. So using both of these factors, you can guess an expected value for that route that was missed, and you can impute or fill in all the missing data and then have a complete data set. So this is what we did for these precincts with missing data. But obviously you do set a threshold, so if a route has missed more than 60% of the counts, then we excluded it. So once we'd imputed the data set, we used the R package pop trend to fit a trend line to these data sets. So that's what you're looking at on these graphs. The lines are indicating the trend line fitted with the GAM, and the dots are indicating the raw data, which is in the units cranes per 100 kilometers, and the blue indicates the error margin. So the where the line is changing color, that indicates a significant increase or significant decrease according to the first derivative of the model. The blocks on the bottom indicate a significant change in the trend, and that's based on the second derivative of the model. So in the SWOT-lines, you can see there's been an overall increase in the period that we looked at between 1996 and 2017. If you look at that a bit more carefully, we see significant increases until about 2007, and then in the summer the trend levels off. Since 2007 until 2017, we saw on average 2.9% decline, and then for the winter the decline was a little more substantial, seeing a drop off of on average 44% decline between 2007 and 2017. And then in the Overberg, we similarly saw significant increases until around 2010. Overall, an increase. In the summer, we saw from 2010, on average between 2010 and 2019, a 29% decline. And then in the winter, it was a little bit more marked, and we saw a 55% decline since 2010. And overall, since 1993, in the winter, we've seen a decline of 11%. So this is a bit concerning because we have such a large proportion of blue cranes in the Western Cape. So with this, these concerning declines that we're seeing in the Overberg, the focus of my PhD is then to try and understand why this is happening. So some of the other next steps that I'm doing in my work is trying to understand breeding success in the Overberg and the Swartland. My project has got quite a strong focus on power line collisions to try and understand how the primary threat to blue cranes, is having an impact. We're then going to try and map power line collision risk using some data that we collect from satellite trackers, and also looking at understanding how cranes interact with the agricultural system. So we're hoping that this research is going to give us some answers and give us some direction on how we can better conserve these cranes. Thank you for listening. Please let me know if you have any questions, and there's my email address below if you would like to get in contact.